I've extracted just a few problems from the quiz. Again, these quiz problems come directly from the homework problems that you've been working already in my math lab. And what I tried to do was to pull out what I think would be the main idea that you ought to definitely be maximizing your time on. So by all means, my logical flow for the class is to, I think when you come here, hopefully if you're following along with me, you should be pretty decent from there to go and do the homework there in my math lab. And then from there, spend some time with the quiz, maybe 2 or 3 times, working through those problems. And then come on in for the test, and I think you'll be fine. So going back to, I believe it was section 1.6, we talked about these transformations of graphs. Remember those 6 basic graphs? You want to make sure you have those in your head. And so then from there we can produce maybe some kind of vertical up or down shift, or horizontal left to the right, that kind of thing. And then also with symmetry, if I take x squared and just put a negative in front of it, then we say that that particular graph is going to be symmetric with respect to the x-axis. But by itself, x squared is going to be symmetric with respect to the y-axis, because I can put a negative inside that x and make that negative x to be squared, and we get positive x squared. So just remember, I think there were 6. So we had that straight line, y equal to x. Y equal to the absolute value of x. Y equal to x squared. Y equal to x to the 3rd. Y equal to the square root of x. What was the 6th one? Was it a horizontal line? Did they give that one? A constant? I think that's what they, I think that would, is that right? The cube root, thank you. Very good. Thank you very much. Beautiful. So obviously that cube root 1 is one that I missed too. So let's see. So this guy, we graphed that. It has a vertical shift down from that x squared. This has a horizontal shift to the left, -3, based on the x squared. Then that negative means is that we're going to have the symmetry with respect to the x-axis. So let's first graph x plus 3 all to be squared. So move over to -3. and we have this guy right here. But then what we want, since it's negative out front, that guy is doing that. So this is the h is equal to negative times x plus 3 to be squared. And you can erase this one once you, bless you, once you get what you want. Let's call that g. This is x plus 3 all to be squared. All right, begin by graphing the absolute value for x. Remember, that's that V shape. So if it's plus 3, that's just shifting up 3 on that one. And so that's a vertical shift, right? So this is that S shape graph. And then plus 5 is a vertical shift up 5. Find the domain of the function. We talked about domains. You want to be very careful with the so-called restrictions. If it's a fraction, what are you looking for? What's the restriction for a fraction? If it's a fraction, what can't happen? If it's a fraction, we can't divide by 0, right? Remember that? So I have to make sure that whatever makes the denominator 0, exclude those numbers from the domain. So I'm going to factor this if we can. So this implies that to make this function undefined, x would have to be equal to 9 and x equal to 7. So we're going to exclude these numbers from the domain. So our domain would go, just look on the number line, just to make sure that we get the right order. Going from left to right, this is negative infinity. And then you get to 7, and then 9, and then plus infinity. So this would be from negative infinity to 7. Is this a bracket or parentheses on the 7? You said bracket? Okay. Now bracket means include that number. Parentheses means about that number, but don't include it. If I include 7, that means that I'm going to have 56 divided by 0. Can't divide by 0, so it's parentheses.
So anytime it says exclusion, you pretty much know it's going to be a bracket, or not bracket,
Parentheses, yes sir. Yep. Then 7 to 9. Union from 9 to infinity. Right? So bracket means to include, parentheses means don't include the endpoint. Okay? Very good. What's the restriction for the square root, for a square root function? Do you remember? Okay, so what's in the under the radical has to be greater than or equal to 0. So this implies that x plus 1, which is under the radical, has to be greater than or equal to 0. Subtract 1 on both sides, we get x is greater than or equal to negative 1. So this becomes our domain. So that is to say, if I'm going from negative 1 to positive infinity, that's a bracket. I can include negative 1 here because I'm not in the denominator all the way to positive infinity. Okay. How many restrictions on this particular function when it comes to the domain? 2? Very good, it's 2. What's one of the restrictions for this one? Can't divide by 0, is that right? Okay, very good. So whatever's in that bottom can't be 0. What's the other restriction? Ma'am? Okay, so what's in under the radical has to be greater than or equal to 0. If you put them both together, what that spells out for us is that x plus 10 has to be positive and not equal to 0, right? Just putting them both together. So subtract 10 on both sides, we get x is greater than negative 10. There's a hole there at negative 10 and everything bigger than that. So our domain would go as parentheses negative 10 all the way to positive infinity. Okay. And then we came to the composition of functions. So f composed with g, we said that's the same thing as f of g of x. But g, we said whatever is the inside function, replace it with what it is. This is x minus 2. So the function f says whatever you give me, it says take the square root of it. So I'm taking the square root of it. I'm giving you x minus 2. G of f of x is, well, g composed with f is g of f of x. Well, f of x is the square root of x. And so g says whatever you give me, minus 2 from it. So I'm giving you the square root of x, and then on the outside, minus 2. Now we take the results from A and B, and we can find the numbers here. F of G evaluated at 3. So I'm just going to plug it right over here because I found part A. This is just 3 minus 2. We just get 1. And then G of F of 3 is the square root of 3 minus 2. Just leave that as it is. Okay. Okay, so find f composed of g and then find its domain. So this is f of g of x. This is f of, now g of x is that 5 over x. This is equal to, f says whatever you give me, this is 8 divided by whatever you give me plus 8. So this is 8 divided by, I'm giving you 5 over x plus 8. Then we simplify that, just use our math. So this is 8 all over 5 plus x, 5 over x plus, we're adding two fractions, I have to have the same denominator, so this is 8x over x, right? So this is 8 all over 5 plus 8x divided by x. So we have a number divided by a fraction, so this is 8 divided by 5 plus 8x all over x. That becomes 8 times x over 5 plus 8x. So that's just 8x all over 5 plus 8x. And that's what we put here. Then it says find the domain of f composed with g. We said that the domain of f composed with g is based on on two domains. It's based on the domain of what I get from simplifying f composed with g, and then also with the restriction of g itself. So here I have two restrictions. Now for the domain for g, x cannot equal to 0. Do you see that? The function g. G is 5 over x. That means that I cannot divide by 0, so x cannot equal to 0. And then for this domain, 5 plus 8x cannot equal to 0. So if I solve for x, I get 8 is equal to negative 5 all over 8. So I have to restrict these two numbers from the domain. Right? So our domain, and let's make sure we get the right order. Well, if a number is negative, it's going to fall to the left of a positive number, or 0. So I have negative 5 over 8, very close to it. I have 0. So this is negative infinity. This is positive infinity. So our domain is negative infinity to negative 5 over 8, parentheses, union with negative 5 over 8, comma 0, union 0 to positive infinity. So how come I use parentheses about the negative 5 over 8 and about 0 and not bracket? Say it again, I'm sorry. Because we cannot include those numbers, because we have fractions, we cannot divide by 0. If I plug those numbers into my denominator, that we end up getting some number divided by 0, and that's undefined, right? Good. All right. So here, the goal is going to be to really see if we can understand what the inverses is all about. Let me just find one of them, then we'll move on. So they want you to find f composed with g of x. So let's put the g of x inside. This is x plus 9 all over 5. Now f says, whatever you give me, multiply by 9, and then minus 5. So I'm giving you x plus 9 all over 5 minus 5. This is pretty good. So this is 9x plus 81 over 5 minus 5, or let's just say 5 for here. So this is 9x plus 81 over 5 minus, here we're subtracting two fractions. We've got to find the least common denominator, which is 5. So I get 25 over 5. So what's 81 minus 25? Hmm? 81 minus 25.
Oh.
All right. All right, so that's what f composed with g is. And then you would do the calculation. That term goes here. 9x plus 56 over 5. And then you calculate for part B. What do you conclude for part C? Are these two functions inverses, or are they not inverses of each other? For two functions to be inverses of each other, what must happen? For f and g to be inverses, what must happen to their composition? Remember, the composition is f composed with g, or g composed with f. For two functions to be inverses, what must happen to the composition? of the two functions. Two functions are inverses of each other. Here, two functions, I need to claim them, f and g. If f composed with g evaluated at x is equal to x, and g composed with f evaluated at x is equal to x. Here, I don't get x, right? So they are not inverses of each other. So you want to watch out for that. All right, here the function f x to the third minus 7 is 1 to 1. It says find the inverse. You remember we said to find the inverse, we replace f of x with y. That's equal to x to the third minus 7. And then we said solve for x in terms of y. So this implies that we have y plus 7 is equal to x to the third. Now to get x by itself, we take the cube root of both sides. So this implies that we have the cube root of y plus 7 is equal to the cube root of x to the third. So here I get x, look at that from right to left, is equal to the cube root of y plus 7. Then we said replace this x with f inverse and replace that y with x. And we get the inverse. Okay. And then it says verify that that both your equation is correct by showing that the compositions would yield x. Well, let's finish out part A. So the key thing here is, can we get the right domain for the so-called inverse? Now let's look at x to the third minus 7. So if I take the function f, and if I get its domain, this domain includes all real numbers. Just the set of all real numbers. And its range, if I take any real number and cube it minus 7, I still get all real numbers. You know, all real numbers just means this, from negative infinity to positive infinity. What do we know about the relationship between the function domain and range with the function's inverse domain and range? What's the correlation? You remember this? We said that where I'm coming from is the domain, and where I'm going is the range. And the inverse just does the reverse. So that means that, look at this, that the range of f is the same as the domain of f inverse. And the domain of f is the same as the range of f inverse. So they kind of swap. But here, for this particular problem, the domain and range are the same. Right? So here, this domain is all real numbers, and the range, all real numbers. So here, that's D for all real, for all x, right? And then you're going to put that function there in here. So then you verify part B, f of f inverse. So f inverse is this cube root of x plus 7. You do the math on that guy. That's going to give you x. Let's see. So this is f of the cube root of x plus 7. F says whatever you give me, cube it. So I'm going to cube this, and then it says minus 7. So this gives us x plus 7 minus 7. We get x. And then the same thing happens over here. This is x to the third minus 7, because that's the function f, which is there. And then here, you work that out, you also get x. And then you conclude that that's verified, right? Okay. Maybe we can do a couple more and then we get out of here. This was the one that was crucial, I thought. It says, given the function complete parts A through C, find the inverse. So here we replace f of x with y is equal to x squared minus 12. Solve for x in terms of y. So we add 12 on both sides. We get y plus 12 is equal to x to the second. Take the square root of both sides. So we get, here for square root, we have to have that plus or minus. The square root of y plus 12 is equal to x. And then we need to determine, do I pick the plus or the minus for the so-called range values for the inverse? Well, the range of the inverse is based on my domain for the function. Well, the domain for the function is positive. That means that the range for the inverse had better be positive as well. This implies that replace this x with f inverse of x is equal to just that square root of x plus 12. You gotta be careful with that, because they could take that same problem and write this as x less than or equal to 0. And then you have to pick negative in front over here. And it's all going back to this. Where I'm coming from is my domain. Where I'm going is my range. Notice that, again, the domain of f is the same as the range for f inverse. The range of f is the same as the domain for f inverse. See that? Same thing. We pick its graph. What do we say about the graph of the function and its inverse with respect to the line y equal to x? They are what? The graph for f and the graph for f inverse are what with respect to the line y equal to x? Symmetric, right? That means you're going to have a mirror image about the line y equal to x. This is not the line y equal to x, right? That's not the line y equal to x. See that? Now I have two that are using the line y equal to x, A and C, but they must be symmetric. Wouldn't that be A? Okay. And then for the domain and range, the domain of f, let's see. So here, this domain would be, this is for f, positive 0, or 0 to positive infinity. Now, if you look at this graph, this goes down, it has a vertical shift down to negative 12. So my range goes from negative 12 to positive infinity. Right. So then for F inverse, it just flips it. The domain would be, it's the range for F, so that's from negative 12 to positive infinity. And then its range is the domain for F that goes from 0 to positive infinity. I think that one there was that guy's the one that I wanted to end with. Now, there are other problems there. You can look at those and you can spend time with the quiz.